But to prep you up, this looks like a lot. It's going to be a little labor intensive first. But this inquiry discovery process we're going to do with these tables and this graph, they're going to build how we're going to graph all of our quadratics going forward, okay? And we're going to look for big ideas. So big idea that we did in the warm-up. The x-intercepts, what's y equal? Someone tell me. 0. And the y-intercept, what does x equal? 0. And we can use those to get our points, right? So what we're going to look here is we have two different functions. We have f of x and g of x. You've got this on your handout. And maybe I highlight these two different colors. Okay? And what you're going to do is you're going to get your table of values. You're going to graph them. Okay, you're going to plot them. And then you're going to make some observations. What are some things you notice, all right? So these are your two functions up here. On your handout, I like to rewrite my function next to my table. You shouldn't need a calculator. All the numbers are pretty small and manageable. And you're going to get after this with your partner. And again, we're going to look for like some big pattern kind of thing. Before pacing, we're gonna get after this a little bit. So just know, I got a chance to walk around and talk to most people. You're taking your x value, you're putting it in, you're getting your y value, that's coming out, right? So I'm going to show you the table. You're going to check your table with your table. So this is what we should have if we did that. Remember, f of x was x times x what? X times x plus 4. And your g of x was x times x minus 4. So the next thing it asks you to do, which I like getting it from the graph actually a little more, but let's find our x-intercepts first. And our x-intercepts happen when? When y is 0. So I'm looking right here, here. So my x-intercepts are negative 4, 0, and 0, 0. And I'm looking here and here, which are 0, 0, and 4, 0. So what's the difference? They're opposite each other, kind of. And I see a connection. I don't know about you. I kind of see a connection to the absolute value function. Do you remember like when there was like a plus happening on the inside, it shifted us left instead of right? And if there was a minus on the inside of the absolute value, it shifted us right instead of left. Do you guys remember that? Yeah. So I just kind of see a connection there. Let's talk about vertex next. Vertex is going to be the high or low point, correct? Yeah. In this case, it's going to be the low point. So the lowest it goes on f of x is, the lowest it goes is negative 4. So negative 2, negative 4. And on g of x, the lowest it goes is also, but it happens at a different spot. That one is 2, negative 4. Okay, so here's what I'm going to give you another minute with your partner. There is a connection to be had between the x-intercepts and the vertex. I want you and your partner to look at those values and see if you can make the connection between your x-intercepts and your vertex, in particular, the x value of your vertex, okay? A minute or so with your partner. Try to see if you can find a connection. Hey, y'all, I heard some good things. Hey, one little point I want to make is if I did not have the table, could I get my x-intercepts kind of quick and easy-ish? Yeah, right? I need to make the whole thing 0. So if that x is 0, or if this x is negative 4. Like, so for practical purposes, I wouldn't normally use a table for that. If this x is 0, or this x is positive 4, right? 0 times junk is 0, right? 0 times anything is 0. So I heard at least a couple rumblings of how you think we got the x value. We could get the x value of the vertex from our zeros. Raymer, what you thinking? Halfway in between both the vertexes? No, both the intercepts. Halfway between the intercepts. Let's check it out. What's halfway between 0 and negative 4? Ooh. What's halfway between 0 and 4? Ooh. So that's looking true. Now, if that is true, when I put that value in to my function, my output should match, right? So if negative 2 goes in, negative 4 should come out. Guess what? It does. Positive 2 goes in, negative 4 should come out. Guess what? It does. So, big ideas. We can get the x-intercepts by making the whole thing 0. That's why we also call those zeros. And the x value comes exactly how far between them? Halfway. That's a big idea that we need to know. Let's say I didn't have the table. How could I find this other value? What could I do with my x value? If I didn't have the table? No. Yeah. Plug it in, baby. If you know an x value, you always know the y value. All right? Emmett, let's check out this graph. So you just are telling me halfway between the zeros. So if I get my zeros, guess what's halfway between? -2 on the blue. Halfway between 0 and 4? 2. And you're going to hear me also. So this says like the x value of the vertex. That's how, your notes are saying it. You're also going to hear me call that value called the axis of symmetry. Which if you just look at what it means, an axis means the thing that something goes around. And symmetry means the two sides are mirror image, right? So a lot of times I like to draw this little dashed line. And I don't hate labeling it as so. The line, the equation of the line, x equals 2 and x equals -2, that's something you'll see. So we got zeros, and the axis of symmetry goes exactly in between. All right? So here's what you're going to do now. You're gonna practice finding that x value, and I'm gonna challenge you to then give me the vertex. It's not a big deal once you have the x value of the vertex. Also, just a reminder, we will also call this axis of symmetry. I like to think of it in my head like when I say axis of symmetry for some reason, like Bill Nye, when he said the axis of I don't know, he says stuff kind of cool with it. Anyway, so get the zeros. Remember, the axis of symmetry or the x coordinate of the vertex comes exactly how far between your zeros? Halfway. Don't do this. I'll just make sure our answers are good, okay? And then you're going to get sketchy number 3. You're going to sketch that graph without using any help. Let's go. So, you're going to notice I continue to focus on concept, Emmett. So, that x right there, what could it equal to make the whole thing 0? -3. So here's one of my intercepts. And this x would be 5 to make the whole thing 0, because 0 times junk is 0. So we learned that the axis of symmetry or the x value of the vertex happens how far between these? Halfway. Right? Thanks, Bob. So halfway between 5 and -3 is 1. And for the vertex, which is the fun extra thing I'm deciding to have us do, I'm going to throw a 1 up in here for x, and I get 4 times -1, which is -4. If I throw 1 in that function, I get 1 plus 3 is 4.
4 times -4.
4 times... Oh, wait. I did something wrong there.
Yeah,
I got you.
1 minus
Yeah.
5
I get 4 times -4, which is -16. Thank you. Okay. The second one. The first is 0. What could I make that x to make the whole thing 0? 0, 0. And I could make that x 3. What's halfway between those?
1.5.
And if I put 1.5 into this function, I get 2 times 1.5 times 1.5 minus 3. That's 3 times -1.5, or -4.5. The last one. This x can be, to make the whole thing 0? -4. And this x would have to be 4 to make the whole thing 0. What's halfway between 4 and -4? 0. Oh, this one's one of the nicer. I throw a 0 up in here, I get 4 times 4. Which is what? 16. That's my vertex. So the big idea is you go after number 3. You're going to work on graphing number 3. How do I get the zeros? By making the whole thing equal 0. Where is that axis of symmetry going to be located? Exactly halfway between those. Once I know that, how do I get my y value?
You plug in the axis of symmetry.
Plug it in, and that's the point that has to work there for your x value, okay? So get after it, number 3. Graph that one, please. So let's start with our x-intercepts. Who can help me with what those are and how they know? Tess.
7 and -1.
So 7, 0, And how do you know? Yeah. If I make that 7, 7 minus 7 is 0. 0 times junk is 0. If I make this one negative 11, 0 times junk is 0. So I already know these points. I know 7, 0. And I know negative 11, 0. Everybody good? Okay. Next, we're going to find the vertex. So I need the x value of that first. Where's that x value going to be, Eliana?
In between the two and like the x.
Not just in between, exactly how far, halfway between. So what x value is halfway between those?
-2.
-2. If you struggle with that, you can always add them together and divide by 2. It works, right? The average or right in the middle of the two things. So not a thing you have to do, but I like to draw my little dashed like line of reference. And I even like to be like, that line's -2. Not a thing you have to. But I know this is going to split my parabola perfectly down the middle. So how could I find that pesky y value if I know the x value, everybody? Plug it in. Right? So y equals -2 minus 7 times -2 plus 11, which is -9 times 9, which is -81. What that tells me is my vertex is -2, -81, right there. And sometimes I even like to write my ordered pair right by it just for organization. Now I'm going to suggest another point. There's another point that's pretty nice. What other point's pretty nice to find?
Well, it has to be 2 of them.
Well, if I find one other point, it'll give me 2 other points. Well, I like how you're thinking about that, Bob. But what about this? If the x-intercepts when y is 0, the y-intercepts when? X is 0. So if I throw zeros in for x, 0, -77 is a point. What is that point? It's got a special name.
Well, access, no, vertex,
Vertex of symmetry.
This is vertex.
axis of symmetry.
No, this is the vertex, which is the axis of symmetry.
Oh, the y-intercept.
Yeah,
Yeah.
it's the y-intercept. When x is 0, this is the y-intercept. That's not a new thing, right? So if this value works, guess what? That value works because what Bob said. It's a mirror image across the axis of symmetry. So if I know one point, I know another point. Unless it's the vertex, that only gives you one. Then I'm going to try to do a good job connecting these points. And then I'm going to acknowledge that if I throw some eyes on here like this and do a little nose, it looks like something. Okay? You'll not be able to unsee that now. You're welcome. All right, so big ideas. Remember, there's way too much to focus on here if you say do this, do this. Big ideas. If I can make one of these zeros, the whole thing is 0. Those are my zeros or my x-intercepts. This axis of symmetry happens exactly what? Halfway between those zeros. If I know that value, what can I do with it? Substitute it to get my y value. How can I get the y-intercept? What does x equal?
Plugging in the x-axis.
By plugging in 0 for x. Another way you can, which is actually the same way, you can distribute and get to be standard form. X squared plus 4x minus 77, and it's right there. Which, I mean, it works for the same reason it worked here. But that's the other way. Too much going on to memorize, do this, do this, do this. Use your big ideas. Let's cool it down. You need to finish this before you get after your homework.